Hey, it's Dr. J. I'm back with part 3 of 4.1, the section on linear functions. I'm just going to continue the applications. Just a little bit more variety, and then I'm going to introduce some economic theory before we wrap up this section. So let's do some more business apps. But this time we have a little bit different information. Suppose you are manufacturing skateboards. So you set up a little factory, and you got cheap rent. You got a really good deal. The monthly fixed costs are $400. So you got cheap rent. You got a cheap little factory. You're going to run a skateboard shop here. You don't have time to come up with all this survey data about, how much it's going to cost to do this, that, and the other. So you just get right to work, and you manufacture 10 skateboards. I'll just say boards. It's easier to write. For a total cost of $900. All right. And that includes the fixed cost. So when I say total cost, I mean including the fixed. So you're probably already doing a little bit of mental math that basically says you've spent $500 more, but we'll get there in a second. Okay. You plan to sell each board, once they're manufactured, for $100. Okay. So I want you to come up with a marginal analysis. So find the cost function, the revenue function, a whole business plan. Yeah. And then I'll ask some more questions, more to follow. I ran out of room. I'm not going to write the rest of the questions, but you probably know what they are. How much are you going to sell to break even, blah, 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 blah. Okay? So this time you have a lot less information. I'm not specifically telling you the cost of everything. I'm not, giving you multiple inputs to move around with. I'm just giving you two simple things. Okay? So we're going to do this whole thing geometrically. Take a different approach. So I'm going to do this kind of neatly here. So I know it's going to go right over my thing here. So this says 400. I'm just going to write that there. And 10 bikes for 900. All right. So take one last look at that. I need to cover it up for a second. Okay. So that says 400, and that said 10 bikes for 900. All right, so we're going to do this whole thing geometrically. Call this old school. All right. There's no specific variables listed in here, so you can pick whatever letter you want to use. Most commonly, we use X, right? It's algebra, right? So we use X. The fixed cost always go on the y-axis. I kind of got to decide how I want to scale this. So let's do 100, 200, 300, 400. So when you do it this way, you really do need to be careful with your scale, because you're basically relying on this graph to give you the answer. It's a slightly different approach, right? So instead of memorizing a bunch of formulas and stuff, you just draw a picture and kind of let the formula come to you. Why go looking for it? You could just let it come to you here. So what's the other information I've got? 10 bikes was $900. Now, I guess I'm just going to count these by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, I don't have to label every number. I tell you what one bike is, and then I tell you what 10 bikes is, and you can use your imagination. Oh, I need to change my scale already. I'm already deciding to change my scale because look, 900 bikes doesn't fit on the scale. So why don't I change this to 900? Let's do it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So sometimes you change your mind after you start drawing. You realize, oh, it's not going to fit on my graph paper. Let's rethink the plan here. So that's 900 for 10 bikes. So that's all I know. 10 bikes cost me 900 bucks. I don't have time to wait around to find out how much it's going to cost to make more bikes. I want to know now. I want the model now. Okay, and then the monthly fixed costs, I had those 400. I'm just moving them down a little bit. So that's 100, 2, 3, that's 400 now. And so this is your cost model. Here it is. Use a dotted line. So there's my cost projection right there. Got it. I'm basically done. Yeah. Well, I got to find the revenue function now. The revenue function is essentially a free answer. All right. So if I put this on the test, which I probably will, you just read it. Look, you plan to sell the boards for $100 each. That's the revenue function. It's 100x. There's no fancy, nothing up my sleeve, no tricks. I didn't have to memorize anything. It's just common sense, right? If you're selling something for $100, then your revenue function is 100x. So 100x, that means 0 is 0, 1 is $100, 2 is $200. What an easy revenue function, right? That's why I priced it at 100 bucks. It's essentially a diagonal line where every board is worth $100. Okay, and then I'm going to label this. And you know what's great about this is if you go into business and you try to convince somebody, or I don't know, has anybody ever watched Shark Tank out there? They love this kind of thing, right? I mean, you could show somebody a picture of what your revenue is going to be, what your cost is going to kind of be. Nobody wants to read all this. Look, so you've just taken all of that and replaced it with that. Yeah? And so there's your model. Let's get our free answer first. That's the easy one, 100x. That's our revenue model. All right. The cost one will be a little bit harder, but not really. I don't even have to do a bunch of calculations. I probably need a new eraser. That's what I need. My eraser just gave up on me. All right. So what do I know? I know the 400. That's my freebie. Remember I called that a freebie? If the problem gives you the fixed cost, then I'm essentially giving you the B for free. So I know it's going to have a plus 400. I just need to figure out what the slope is, the rate of change. I can do that all right here. Look, 900 to 400, so it's going up $500. Yeah, we already kind of mentally figured that one out a long time ago, right? Probably as soon as you read the problem. It's increasing $500. And it's going over 10 bikes, or bikes, skateboards, whatever. Right, 10. So the slope, 500 over 10, 50. Yeah. This is the cost to produce each additional bike. Of course, after I've paid the rent. Yeah. So there's my A, 50. There you go, right? Did the whole thing geometrically. And now if you want to answer all of the subsequent questions about things like, I don't know, break-even points or what have you, margin of profit, So our margin of profit will be over here, past the break-even point. Let's go ahead and find the break-even point. That's one of the first questions you'll typically ask. Where's the break-even point? We just look at the graph here. 1, 2, 3, 4, 5, 6, 7, 8 bikes. So you're going to break even. X equals 8 bikes. Why do I keep calling them bikes? Boards. I think in the last video I started calling televisions refrigerators halfway through the lesson, but I hope that doesn't change the the process. It doesn't matter what these are. When I was in college, we used to call them widgets. It didn't matter what you were selling, right? The teacher would just say, oh, you're going to produce X number of widgets or whatever. So in this example, I happen to be calling them skateboards. Okay, so there's your revenue. There's your cost function. We know when it's going to break even. You could ask all kinds of other questions. If you sell, I don't know, something less than 8, I don't know, 5 bikes. What is the margin? I'm just asking all the kind of general questions that you might have. And you can just look at the picture and answer them. What is the margin? Profit. You know it's going to be negative. All right, so let's come over here. We've got 5 bikes. If you can even read that, that's a 5. We know it's going to cost us how much? How much are we going to make on 5 bikes? That's $500 for 5 bikes. But the cost for 5 bikes is a little bit higher. Yeah. I ended up in the middle here. So we got 4, 5, 6, 50. So that's 650. If you're not sure, you can actually put it in here. Look, 5 times 50 would be 250. Yeah, and then plus the $400 in rent or whatever, so that's 650. So the margin of profit is 500 minus 650, which is negative $650. So that's a loss. So anyway, I just wanted to put that out there because sometimes you'll have problems and you want to work it a different way. You want to think about it geometrically. It's certainly a little bit more intuitive. You can kind of see if you make a mistake, right? I mean, mistakes can happen with algebra. You'll be plugging in numbers and calculating and you won't even realize it happened. I mean, you've seen me do that a ton of times. But when you can see it right in front of you, that's why, business people love charts and graphs and things like that. Well, they'll give you a way to look exactly what's going on here. Now, before we move on, I want to just say one thing about this problem before we let it go. In Chapter 5, we are going to learn a more sophisticated model that's nonlinear. All right? So I need to give you a little bit of economic theory. Just a little bit. I'm not an economics teacher, I'm not going to try and replace the course that you'll probably take, or maybe we'll take on economics. What I'm going to do is give you a little bit of a mathematician's perspective of the economic theory. And that's that we assume, so X is the number of units. Or skateboards or widgets or whatever it is, bicycles, refrigerators, televisions, it really doesn't matter. And we assume this goes to infinity. But that's a bad assumption. Whenever I do an algebra problem all the way through Chapter 3, we assumed, with graphs like this, the domain would go on forever, right, to infinity. In fact, in a lot of the graphs I drew went the other way to negative infinity. Yeah. But we can't assume that, right? First of all, there's not even an infinite number of people, right? So how are you possibly going to sell an infinite number of bikes, right? And so X in economic theory is called demand. It's basically what the market will bear, you can only sell so many skateboards, you can only sell so many bikes. And pretty soon the market gets flooded with bikes. And what happens is the price then goes down, right? and it's related to price. Yeah. So there's an invisible variable here, right? It's in here, but you can't really see it, right? I don't know, but if you look really carefully, you can see it, right? Where's the price in here, in this graph? Maybe I can erase some of this messy stuff, and maybe it'll make it easier for you to see it. All right, so suppose you just have this graph here. What was that? 400, and then 500, or 900, and so on and so forth. Now it's a little bit easier to see. All right, so this was your cost, and this was your break-even point, and I'm just going to erase that red line because that's not really there. Okay, and then this is your revenue. Can you see it? Can you see the price in there? Look really hard. Look right in here. Look at the revenue. The price of the bike was $100 each. Yeah. I was selling the bikes for $100 each, but I don't really have a variable for the price. So what happens if the demand affects the price? Suppose the price goes down. You know, suppose I got too many skateboards and I got to get rid of my skateboards, and now the price goes down to $80. Well, this is no longer going to be a line, right? Because it'll still be a line. It won't be this line. It'll be a different line. It'll be a line that's a little bit less. And what would happen is revenue would go like this now. Yeah. And I'm not being very precise, but it's going to be $80 instead of $100. So this first dot will be a little bit lower than $100. And then each subsequent dot will be a little bit lower. And then what happens to my break-even point? My break-even point moves. Now I have to sell more than 10 and oh God, how can I sleep at night, right? So what we're going to do next is economic theory, because this is now a little bit of a social science, right? Economics is not like math in the way that there's just a right answer all the time. Economics deals with the way people behave, right? Whether or not somebody will pay $80 for a skateboard, or $100 or something like that. So what we're going to do next is we're going to not talk about cost anymore. We're not going to talk about revenue. We're just going to talk about price and demand. Okay. How does the price affect the demand, and how does the demand affect the price? So we basically are going to come up with two new models. Since they're in chapter 4 still, they will be linear models. You already know the recipe for a linear model. So let's just go for it. I think this is only example 2, isn't it? Yeah, I just did one really long example 1. Okay. Example 2, price and demand. Suppose a particular item. This time I'm not even going to fake it. I'm not going to make up refrigerators or skateboards. I'm just going to call it a particular item. When priced, I got to make sure I get the numbers right at this. At $32 per item, $32 each. My dollar sign was awful. Here, let's just go 1 or 2. There we go. At $32 each, the demand is 220 items. Now, demand is loosely defined. It's going to be X, and it could be per day, it could be per month, it could be per whatever, week, whatever we want it to be. We're not going to go there right now. Again, that's something we'd have to cover in a future course, because it starts to get really complicated when you bring in time. All right, so just think of X abstractly as however many you can sell in some period of time. All right. Because if I do time, then I have to bring in another letter, which is T, and then all of a sudden these equations start to get really nuts. So we want to keep it simple. We're only going to do price, so price will be P and demand will be X. X is the number of items. All right, so we got our P, we got our X. Let's call that price 1 and X1, because it's the first one given. However, when the price is lowered, to $24 each, the demand increases. That's a good sign. They want more because you're selling it cheaper. To 300 items. Now the way, if you actually were doing this, you would just kind of keep track. You would do it every month. You probably wouldn't do it per day. I mean, I don't know, maybe if you're selling a lot, but I'm talking about like small business, So this is our second price, P2, and this is our second demand, X2. Then the price demand function PX is equal to AX plus B. We call this the price demand function. In other words, it gives us the price in terms of the demand. It's also called the price equation. So it's the magic equation that tells you what the price of something should be. It's again a predictor, right? It says, well, if the demand is X, then you plug in X and this formula will give you the predicted price. So it's kind of cool. It's like having a little price machine, yeah? But it uses math instead of just guessing. What do you think you should sell it for, right? Okay. Now we have to actually figure this out here. I got to take all this information. So I don't know what A is and I don't know what B is. And either will you, right? You'll have to figure them out from the given problem. Okay. So let me just write everything down so I can erase all this. So I got 32, excuse me, I got to put it in the right order. So P is acting like Y, right? So I've got 220 and then 32. That's going to be my X1, P1. If that bothers you, you certainly are allowed to use X and Y, and then when you're done, just remember that Y is actually P. All right, and then what's my other point? My other point is 300 and then 24. That's X2, P2. All right. So this one I'm going to do it totally algebraically. So we sometimes call this blind, right? So I'm not looking at the actual picture, but you certainly could take out, your graph paper and do it that way. So I got 24 minus 32 over 300 minus 220. So I'm going to get negative 8 over 80, which is negative 1/10. Or if you prefer decimals, negative 0.1. Okay, there you go. Got your A. Just the slope formula. Does it make sense why it's negative, I hope? Yeah. Because as the demand increases, the price goes down. Yeah. And vice versa. As the price goes up, the demand decreases. Now we need to find B. There is a neat trick, if you like. Might as well. I don't want to call it a trick. Let's call it a technique. A trick makes it sound like I'm trying to trick you or something. So the technique to find B is to use the point slope. Remember that one? So it's P minus P1 equals A X minus X1. Remember the old point slope formula? The Y's are now P's and the M is now A. It's a nice trick. Oh, nice technique. There I go again. All right, so I'm going to use P1 and X1, although you can actually use either one. It doesn't really matter. So you got P1 is 32. My A is negative 1/10. And my X1 is 220. So what's cool about this technique is that it just pops out the B value without really too much effort. Right? You don't have to go looking for it. It comes to you, which is always much better than hunting, right? You just sit and wait. I'm just bringing it up here because I think I ran out of room down there. I don't know if the camera can see that. So I'm going to write it one more time at the top, and I'm almost done. I just got to move that 32 over. And there goes the B. I didn't really talk about how I got 22. I hope that's clear. I multiplied it by a negative and a negative, so it turned positive, and it's 1/10. Yeah, 1/10 of 220 is 22. I didn't even have to break out the calculator, but you certainly are allowed to. So you get negative 0.1x plus 54, and there's our B. Not 544. I don't know why I wrote that. 54. There we go. Man, having some serious erasing problems today. There we go. All right, and then to make it look like a function, because technically this is the price equation, but if you want it to look like a function, it's negative 0.1x plus 54 using function notation. So all that means is I put the x in parentheses so it looks like a function. All right, so it's really the same thing we were already doing. A couple things to point out is I should be using a lowercase p, not a capital P, but I started to write capital P's. Somewhere right around here, my P's started to get larger and larger, and that could happen to you too, right? Because a P, a capital P and a lowercase p are so similar. And if you're writing really, really fast, and if you're like me, your P's might start to look like capital. Be careful, this is not profit. Profit also uses the letter P, but profit is a capital P and price is a lowercase p. And some people don't like that, and so they'll change the letters, but I'm not going to. I'm just going to tell you, be careful. There's a difference between the capital and the lowercase. Might not seem like it matters in your notes. It really doesn't. But it will matter when you type in the answer. You got to use the lowercase p, okay? So now you can take this answer. So this is the price-demand equation, or sometimes just called the price equation. Can be rewritten in terms of P. Again, that's supposed to be a lowercase p. See, doing it again. In other words, I can switch it around, and I can call this the demand equation, or the demand function. So the price equation predicts the price, yeah? The demand equation predicts the demand. It just basically turns it around and says, well, if the price is $1,000, how many people are going to buy it, right? So let's see how that works. Let me just write this over here. Just for my notes, I like to just write P. It's just much easier. Get rid of the function notation. You'll see why in a second. So plus 54. So this is the way I want to rewrite it. I don't need to do the whole problem again. I mean, unless it's a new problem with different numbers. I'm just going to keep rolling with this one. So if I take this and I solve it for x in terms of P. Solve for x in terms of P. And that's why I take away the function notation. And I actually do one more little technique. I put the P on the right-hand side, because I already know I want my final answer to be in terms of P. So I'm kind of just setting it all up so that I don't have to move it around later, right? And so I want to get X by itself. So let's subtract the 54 from both sides. Again, I don't have to tell you how to do this part. You've been doing this since your first day in algebra class, right? I hope so. And now you want to divide everybody by negative 0.1. Now be careful. You might have developed some bad habits in your other classes. You got to divide everybody by negative 0.1. Some people try to be cheap and just draw 1 divided by, and that typically doesn't work out very well. So this will be negative, what? Here's a cool technique. 1/10 is 1 over 10, right? And then this one's going to be 2 negatives, which will be a positive. 1 over 10, and I'm just putting the negative out in front. I can flip it, and that'll become 10 over 1. All right. Or I could have just used my calculator, but I was just being lazy and not reaching 10 feet over there to grab my calculator. And I don't need to put the over 1 part, so it's negative 10p plus 54. This now can be written as a function. And you probably haven't seen this before. X is acting like Y, and P is acting like X. So this is called X of P. This is the demand equation. All right. And so that's why we call this price and demand. So let me put them side by side. Price equation, or price function, same thing. Also called a price model. I don't want to write all those words down, but they all mean the same thing. P of X equals negative 0.1x plus, what was it, 54? Yeah. I think I made a math error here. I'm glad I caught it before I erased it. 54 divided by 1/10. I also need to divide that by 1/10. So that's 10 over 1, so that's 540. Probably would have discovered that as soon as I asked any additional questions. As soon as I say, hey, what's the price, that would have definitely pointed out that it was wrong, but I almost blew it. I was too busy worried about the negative 10 over 1 thing, and I completely forgot about the 54, but we got it. All right, so this is price demand. They're essentially the same coin. It's like heads and tails, right? Really is what this kind of means. So what should the price be when the demand is, I don't know, 500 items? Well, you're going to use the price equation. Yeah. So you plug in 500, negative 0.1 times 500 plus 54. That'll be negative 50 plus 54, $4. Whatever this is, I don't know. If the demand is 500 items, you could lower the price down to $4. The demand equation will give us the ability to predict the demand. What will the demand be if the price is, I don't know, how much should we make the price? I don't know, $20. What will the demand be? The price is $20. All right, well, now we're going to use the other one. We use the demand equation, plug in P. as our input. So what's weird about this is x is kind of acting like the function now. When in the old days, x was the input. Now x is actually the output. We get negative 10 times 20 plus 540, negative 200 plus 540. The demand would reduce to 340 items. So you can see how the price and the demand are interrelated. As the price goes up, the demand goes down, and vice versa. I'm not going to get all into graphing these things because we've already done a lot of graphing of straight lines, but these are both straight lines. They both have negative slopes, so they both go down. And then we typically ignore negatives, not in terms of the answer, but in terms of the value. So if you got a negative price or a negative demand, then that would not make any sense, right? Both of those things should be positive numbers. Yeah, you can have a negative slope, but that's really it. The negative slope is just telling you that the graph is going down. All right, I think we did it. That's about it. Now, these two equations are going to be revisited in Chapter 5. So for now, this is about all you need to know to get through this portion of Chapter 4. And until we meet again, this is Dr. Jordan reminding you to see me on the internet.